Hello, Professor. My name is Naiba Shabanova. In this video, I will walk you through my assignment for Unix 5.1, which focus on the implementing and embedded debug logging system in C++. This logging system helped me track unexpected behaviors in production environments by embedding logs directly inside the application code. So in this project has the three main components: a logger responsible for the collecting and filtering logs and sending them to the server. For the log server, I receive the logs over UDP and write them to a file. Travel Simulator simulates car behavior and generates log message. The logger uses for the severity levels like debugging, warning, errors, and critical. So I will show you in the Ubuntu. It's only the send log that match or exceed the current filter level to ensure the performance is not affected. So let's go to the my code. I have here the logger.h, and also I will explain you the code logserver.cpp. But before that, I want to show you my I use the two files for the server file. I used all of them here. So another one is process. So I use the two files. So first of all, I want to explain code. As you see, it's starting the port number and the listen on, and also IP address to bind local host file to store receive log message. So for the starting signal handle function, like handles control S or other commands, dump log in the command one received, not use the by signal, but includes shutdown if commands are received, not use the by signal. So here is initialize the length of the remote address, set handler here, control S. So when we dive in a bit down, here we can see initialize the address structure for binding the socket, like convert the IP. So here we can see bind the socket to the IP and port. Here I added the mutex for initialize the mutex and also create and start the receiver serve. Mini for user interactions. Option to set the log level on client and log to avoid conflicts. I used here mutex logs. So option to dub log file content to screen. Wait for treat to finish here and close the socket and return. So treat function that receives logger message and writes to file. Open the log file with the read-write permissions. And also here has a sleep 1 second and write received log the file. Here is exit treat and dumps the log file content the console, and finally gratefully shut down the server. So log server is like built using UDP sockets and the multi reading. It includes the menu with three options: set the log level, dump the log file to the screen, shut down the server. So as separate retrieve function writes all the received logs into the file called log file. So the server also responds control C signal to the shutdown gracefully. So let's go to Ubuntu. As usual, I did about it 2 times. Yeah, it's my second time. Yeah, I mean the videos. I use the two terminal, as you see, it's two terminal. So what I used for the terminal, for the starting, I just here as you see the result, set the log level. But before that, I just go to the pathway for the assignment 2, and also I use the make file and also dot logger server. And after I got this result, set the log level and dump the log file where and the shutdown. So it's like leave the window. I leave the window here, so it's coming here. I open here, see the assignment to again, unless I see here process and server. And at the assignment 2, I came the process. And after I use the make file and compile it, and I use the dot travel. So after I can see here, as you see, the debug uh, and also warning. Uh, all are here, as you see. So my as you see, my Ubuntu is working, but altogether, I want to say that one of the main challenges I faced during this assignment was the understanding how UDP sockets work and how to properly structure message between the logger and server, setting up multi-threading and making sure the share resource were correctly protected. Using mutex also took the time and carefully debug. I had to ensure that logs were being filtered based on the server and the receiver that didn't interface with the main thread's operations. Another challenge was the maintained synchronization when updating the log level from the server side without causing conflict in the client logger. Despite challenge, this assignment was like help me to understand the socket programming and practical importance of embedded logs for debugging in the field. It was hands-on experience with the real-time logging and system-level communication. So yeah, I done, and it was the great. So thank you, Professor. I hope you like it. I did my best. Yeah, see you. Bye.